In this video, I will be performing the famous Reimer Tiemann reaction. For that, we need 56 grams of potassium hydroxide, 12.5 grams of phenol, and 20 ml of chloroform. So first I measure 56 grams of potassium hydroxide. Some potassium hydroxide is stuck inside the jar, so I added some water in it to dissolve. I added 25 ml water in the jar and 15 ml water in the beaker and let it dissolve. I could have used sodium hydroxide instead of potassium hydroxide, but after reading a research paper, I found that potassium hydroxide gives a better yield than sodium hydroxide. Then, in a beaker, I took 12.5 grams of phenol and added 12.5 ml water to it. Phenol is not very much soluble in water, so even in the liquid form, it does not completely dissolve in water. Now, in a 3-neck round bottom flask fitted with a condenser and thermometer, the phenol solution was added. Phenol should be handled with precaution as it is corrosive. Then, a pear shaped magnetic bead was added, and with stirring, potassium hydroxide was added slowly. Then, a pressure equalizing addition funnel was attached in the third neck. The addition funnel was loaded with 20 ml of chloroform. Then, the reaction mixture is heated to 60 degrees Celsius. When temperature rose to 60 degrees Celsius, some chloroform was slowly dripped in. On addition of chloroform, reaction mixture started turning cloudy and temperature started rising. So I switched off the heating mantle. Slowly, as the reaction proceeds, the color of the reaction mixture starting getting dark. The temperature rose to 75 degrees Celsius. So I stopped the addition of chloroform and waited for it to come in between 65 to 70 degrees Celsius. So what's happening here is chloroform reacts with potassium hydroxide to form the intermediate dichlorocarbene, which then attacks on the phenol preferably at ortho position to form salicylaldehyde. Some 4-hydroxybenzaldehyde is also formed as the minor product. In the reaction, the phenol, salicylaldehyde, the 4-hydroxybenzaldehyde exist in the phenoxide form due to alkaline environment. When temperature came to 70 degrees Celsius, I again continued the addition of chloroform. When temperature started falling below 70 degrees Celsius, I again switched on the heating. When all the chloroform was added, which took me around 1 to 2 hours, the mixture turned more dark. This is happening due to formation of colored side products. This is one of the major reasons for low yield of salicylaldehyde in this reaction. Now I need to heat it at 100 degrees Celsius for 1 hour. I took out the addition funnel and placed a glass stopper and turned the heating mantle at full heat, but still temperature of the reaction mixture could not rise above 75 degrees Celsius due to refluxing chloroform. So I replaced the heating mantle with oil bath which was preheated to 200 degrees Celsius. Then temperature rose to 85 degrees Celsius. It was continued for 1 hour and then I checked the TLC. The substrate, that is phenol, was still left in the reaction mixture. So I left it overnight at it was getting 1 am at night and I had to go to sleep. The next day I saw that the reaction mixture had turned dark brown, though I had stopped the apparatus to prevent air from going in. For some reason, the phenol doesn't get completely consumed in this reaction despite the fact chloroform and potassium hydroxide are in large excess. I arranged the apparatus for steam distillation to remove unreacted chloroform. Chloroform has a low boiling point of 56 degrees Celsius and forms an azeotrope with water, so it gets easily distilled off along with water, due to which distillate is cloudy. When distillate is no more cloudy, I added concentrated hydrochloric acid to the reaction mixture to acidify the mixture and swapped the receiving flask with a fresh one. Around 50 ml of 10 molar hydrochloric acid is required to acidify it. Upon acidification, the reaction mixture should have decolorized, but it did not happen here. I think leaving it overnight had ruined it. In the flask, you can see some solid floating around. I stopped the addition of hydrochloric acid when pH was around 1 and again steam distilled it to remove salicylaldehyde as it is steam volatile, while para-hydroxybenzaldehyde is non-volatile and won't be steam distilled. The unreacted phenol will get steam distilled, which would lead to doing an extra step to purify salicylaldehyde. When the distillate stopped coming cloudy, 25 ml water more was collected and then it was discontinued. The apparatus was dismantled and the residual solution was filtered hot. The solid which you are seeing in the flask is the tar, the black one, and the orange solid is the potassium chloride. I again added more water in the flask, heated it, and again filtered it. I repeated this process 2 to 3 times until the solution became colorless. On cooling, some crystals are formed, which majorly are of potassium chloride along with 4-hydroxybenzaldehyde. In the round bottom flask, we have the steam distilled fraction, which contains salicylaldehyde and unreacted phenol. To purify it, I took 8 grams of sodium metabisulfite and added it to this solution. The solution is acidic, so sulfur dioxide gas is evolved. So the stopper had to be taken off after each shaking. The sodium metabisulfite reacts with water to form sodium bisulfite, which then forms the addition product with salicylaldehyde. It was left to rest to react. Until then, I started with extraction of 4-hydroxybenzaldehyde. For that, I added dichloromethane to the yellow solution and shook it and let it rest. Then I transferred the contents into a separatory funnel. I washed the residue in the flask with some DCM and drained the lower DCM layer. Then I transferred the DCM from the flask into the separatory funnel, capped, and shook the flask with venting. I dissolved the residue in some distilled water and added some more DCM to it and transferred it into the separatory funnel. I then drained the lower DCM layer from the separatory funnel into another flask. I repeated one more extraction with DCM. All the DCM extracts were combined and to it some anhydrous sodium sulfate is added. To clean the reaction flask, I added some sodium hydroxide to dissolve the tar and a dark red solution was formed. This is the bisulfite adduct of salicylaldehyde, which has precipitated. Now we can remove the phenol. I poured the solution into the separatory funnel, added some distilled water in the flask to dissolve the adduct and poured it into the separatory funnel. Now to it, DCM was added. The separatory funnel was capped, shaked and vented and allowed to rest, and the lower DCM layer was drained off. Washings were repeated. Meanwhile, the DCM layer was separating. I decanted the dried DCM solution of 4-hydroxybenzaldehyde into a round bottom flask. The sodium sulfate is washed with some fresh DCM until yellow color fades away. Even after resting for so long, the aqueous layer did not clear up, so I decanted the lower DCM layer and added some diethyl ether to the separatory funnel, capped, shaked, vented, and allowed to rest. After some time, aqueous layer cleared up. The lower aqueous layer was collected in a round bottom flask, and the upper ethereal layer was discarded. To the aqueous layer, 8 ml of concentrated hydrochloric acid is added to decompose the bisulfite adduct and free the salicylaldehyde. On the addition of hydrochloric acid, the solution turns cloudy. As salicylaldehyde is formed, this solution is then warmed in a hot water bath for 5 minutes, and you can see salicylaldehyde formed at the bottom. All the solution was transferred into a separatory funnel, and the round bottom flask was washed with dichloromethane, and washing was added to the separatory funnel. The flask was capped, shaked, vented, and allowed to rest. In all this process, lot of sulfur dioxide gas is released, so it should be performed inside a fume hood or in a well ventilated area with a gas mask. The extractions were repeated up to 3 times and collected in a conical flask, and to dry it, some anhydrous sodium sulfate was added. I ran a TLC. On the left is reaction mixture, in the middle is the salicylaldehyde, and on the right is 4-hydroxybenzaldehyde. All looks impure. Anyways, I boiled away the 4-hydroxybenzaldehyde DCM solution on a water bath, and the residue left was boiled with some water, to which I added some sulfurous acid. Boiling would remove any residual DCM and allowed it to crystallize. The salicylaldehyde solution of DCM was added to a round bottom flask. The sodium The sodium sulfate was washed with DCM, and then all the DCM was removed on a water bath, and I was left with a liquid which weighs 1.4 gram. This is salicylaldehyde. The 4-hydroxybenzaldehyde is precipitated along with impurities. It was filtered off, dried, and the final yield was 0.4 gram. The yield is very poor. Vogel reports a yield of 37% for salicylaldehyde, while mine was only 8.63%.